Hola, hola Alicante, and that's the end of my Spanish. Yeah, sorry, I can maybe try to do that a little bit more in Portugal, but I won't because it's broken too. But yeah, it's great to be here. There's an amazing coffee break right now. I hope you're all uh, fed but not too full. I would hate somebody to go into a food coma during my talk. Please don't fall asleep. It's gonna traumatize me a little bit. No, just joke. Yeah. Yeah, but it's great to be here. Great to see you all. And yeah, can you just help me thank the organizers of this conference, because I wouldn't be here without them. I got 2 flights canceled. I freaked out like, I don't know, 5 times. And they just text me, look, I'm lost in my dream. I'm here, my flight's not here. Please help. And they just said, yeah, chill out. You're going to be here. And I made it. So can you please help me, like, giving them a round of applause? Thank you. But yeah, let's talk about monorepos. First of all, who am I? I'm ATILA or ATILA, like whatever rolls out of your tongue the easiest works for me. My pronouns are he and him, and I'm actually a DX engineer at Zata. We are a startup on the serverless database market. We're actually like a data layer, a serverless data layer. And the reason I'm telling you this is because there's one thing that's really important for us, which is developer experience. Because we're a product for developers, we go really overboard on trying to give the best developer experience. We give each other a really hard time when we have a feature that is done, but then we could improve how our users are going to interact with this feature, and so on. So we take it very, very seriously. We want to be like the best developer experience we can be, maybe in the world, I guess. Yeah. So we can give the best developer experience possible. And there's another thing we're really passionate about, which is open source and sharing stuff. So this talk actually came from my day-to-day work, because when I was tasked about working and creating samples and integrations with data, I told my team, look, I want to build this, I want to do this, but I do not want to be setting up multiple repositories and so on, and handling all the day-to-day tasks every time differently for each one of them. And I don't know, allocating 1 or 2 days of my week to go updating dependencies and cutting out releases and writing change logs. And my team said, yeah, we'll fire you if you do that. No, I'm joking. Yeah, no. They actually said, no, let's do something really cool, and let's try to make a good developer experience also for us, because if we do, like, developers are our users. So if we have a good developer experience when we're building our stuff, our users can have a good developer experience too. So then, with that in mind, I decided to create a monorepo. And here I'm going to share to you today my experience on setting up this monorepo, and what are the cons, and really the cons first, and then the pros of having the monorepo. Because when we think about, when we're advertising a new technology, we tend to look at what it gives to us first, but then once we start implementing, we see, okay, so where does it go into step on my foot? Like, what are the things that it's not going to do for me, and what are the things I actually need it to do for me? So in order to get to that, let's first set a baseline by defining what monorepos are. And I don't enjoy like creating definitions and stuff like this, so I took this one from this awesome resource. It's monorepo.tools. And the definition is that it's a single repository that contains multiple distinct projects with well-defined relationships. And the key word on this is relationship. Because if you just have multiple projects in the same directory, yeah, you just have a lot of projects in a folder. But the relationships are not defined necessarily by dependencies. The relationships can be described as common processes, or common guidelines, common standards. So not necessarily they are intertwined, and that's usually something that people point out when they don't have a good experience with monorepos, is that they got too much intertwined in a bad way that they say end up becoming a monolith. But that's actually part of the problem. That's part of the things we're going to address today. Relationships between our projects are good, and I hope you agree with me by the end of this talk. So to have a good sense of what's a monorepo, I like the brain analogy. So just think about everything we know as little pieces of information that our brain, as a single repository of this information, is going to access. So if you speak a language, for example, or walking, or your favorite furniture store, I guess. So all these are little pieces of information that whenever you need, they are either going to be related to each other or you're going to make use of them to a certain time. And a common issue that we have on monorepos is essentially when a dependency goes missing for different reasons, different ways, but essentially it's missing. It's not where it should be, or it's a different kind of dependencies that it should be. And it also happens to our brain when we have like a big hit to the brain, or if we drink too much, or if we're too tired. Sometimes we just like forget stuff, you know? And that happens when essentially it's a bad deploy, a dependency went missing. So basically when we do to access if a dependency is missing, we make integration tests. And that's essentially what you see people doing in like concussion protocols, for example. You just ask, okay, like, can you raise your left arm? Then you raise the wrong one. Yeah, there's like dependency problem there. So that's essentially it. Like in a nutshell, that's like our brain is a monorepo, basically. And now that we're done with defining stuff, and as I mentioned, like there's all the things that we know it's nice about having a monorepo, but we need to address this little elephant in the room, which are the problems that are like module resolution. That's particularly bad. It's essentially when there's a specific kind of problem that the dependency is there, but it's not the dependency you want. It's not the dependency you're looking for. Who deployed the same two React packages to the same monorepo, and you end up getting a console log error that context is not defined, right? So then you have like other problems where you're cutting releases, you're versioning your packages, and that becomes such an annoying piece of work at some point, like after you do that for the 5th time or so. And then you start getting into more complex issues, which is how you're going to orchestrate your build. Which packages are going to be built first, which packages are going to be built last, which tasks on each package, and so on. And then you get to the big, big problem, which is CI times. So continuous integration, I missed that word. Continuous integration can be a problem because it's expensive. And then if you put everything together and you need to rebuild the whole kitchen sink every time you want to change the temperature of the water, it's gonna be annoying. It's gonna take, I don't know, 10 minutes, 15 minutes, and you just changed a JSON. That's not nice. And then you get all the chores. You get to write changelog, you get to write documentation, you're going to do update dependencies, and then the dependencies you need to synchronize because there are different packages using the same dependency and one of them has a problem. So we want to cut down all this, and all this stuff pile up really fast and really easily. And then if you don't think about that ahead, you end up thinking the problem is monorepos architecture as its own, and it's not. We just need to set us, like, with all the things on automation and abstraction, we need to take a step back, set ourselves up for success, and then we can take the advantages of them. So to go a little bit further about module resolution, and what does that mean? I'm going to take again our brain metaphor here. In my case, like I speak Brazilian version of Portuguese, and since I'm here, I've been trying to speak a little bit of Spanish, but it doesn't work. But anyways, and as most of you probably know, Portuguese and Spanish, they have a common dependency, which is in this case an external dependency, which is Latin. Both are Latin-based languages. So essentially, every time you're deploying a Brazilian language package, you're doing npm install Latin and so on, and this kind of stuff. And there is a specific word that's very common here that I'm guessing, don't take me for it, but I'm guessing it comes from Latin, tapas, because it also exists in Portuguese, at least in Brazilian Portuguese. There's some Portuguese people here, so if not, I'm sorry. So yeah, but yeah, you have that on both Spanish and Brazil, but they mean different things. So when you're in Spain, tapa is a really nice thing. It's like this dish with food, and then if somebody offers you tapa, you're gonna take it. It's nice. But if you're in Brazil, you probably want to say no if somebody offers you a tapa. Because that's a slap, and you don't want to get slapped. So we have two versions of tapa. We have the food version, and we have the aggressive version. And if I have both languages here, I really want that dependency to resolve well, because if somebody asks me for a tapa, or if somebody offers me a tapa, I want to know which one I'm going to respond. And if my monorepo is not well set, what's going to happen here is that, and sorry if there's a misspelling in my Spanish, but I think that's it. So if somebody's going to say, ¿Quieres unos tapas? I'm going to, oh, tapas. Okay, I need to parse that. Yeah? No, please, no, definitely not. So that's a problem when there was actually a dependency confusion here, and that happens so often when our tooling is not well set, and there's some sets of toolings that do the dependency, they hoist their dependency to the top level, and they just symlink to each package. And then this can happen when you have different versions of the same package, and then your log file, you're going to see there's like, I don't know, React, and then 17.8, like 16.5, 16.5.2, and so on. And then 17 and 18 and so on. And then what's going to happen in real world scenario is that you have your React app deployed, and then one dependency is using one version of React, another is using another one. And even if they don't break, they have different instances of React. And then you get the one that context not defined, and then you look your code and it's perfectly fine, but still breaking on runtime. So that's what a bad module resolution is. And then we get to package pipeline, which is another big problem. This is a problem that creeps out as your monorepo grows. Like when it starts, it's pretty simple. Like you start with one or two packages. So you set up linting or statistical analysis. Then you're going to test, like unit test, whatever these tests are. And then you build their stuff. Then you do some integration tests, hopefully. And finally, you're going to ship it. Either you're deploying your app to some kind of server platform, or you're publishing it to npm package. Like I put ship there because it doesn't matter at this point. And then this is essentially how every monorepo starts. Like you have a bunch of packages and you say, oh, I'm going to put them together because I essentially want to ship them together. Or there is, like, it's the same team that's maintaining them, so it just makes sense. It's one repository, so I don't get lost between repositories. I clone only once and so on. So you get these 4 little packages, and then your monorepo starts growing. And then you get some other packages, but these packages are special because you have dependencies. They depend on their sibling packages. And some have similar dependencies. So now you have, for example, red over there that's used by 2 of them, or blue over there, or green even. So you need to be extra careful when you're publishing changes or you're building changes to those packages that are depended on, because the last thing you want is run your whole orange pipeline on an old version of red. So it either doesn't get your bug fix, doesn't get your feature, or it essentially breaks because you made changes to both of them, and then you get your APIs out of sync. And then things start getting even wider because now I have all these packages, and you can think, for example, like red is my design system token, and then orange is my design system, and then I have pink that is my app that's using the design system. So as you can see, there's somebody that imported that token directly into my app, and I have the whole design system there as well. So I have different levels of dependency. As you can see, this can grow pretty complex pretty fast. And these are interdependencies, essentially. So this is the best and the worst thing about a monorepo. So they can save you a lot of time, or they can hurt like a lot. So the first impulse we get is be very pragmatic about it. And we take the pipeline as it would work on a regular repository, and we say, okay, I need first to lint, then I test, then I build, and then everything, and things keep going, like all of these, and then all of that, and then all of that. Because then if I make all this, I know that by the time that I'm going to start building my package, the test was gone, and it happened. So then I just need to define the dependencies, and then one build is going to wait for another. So then you need to finish all the builds. Like, again, you cannot build pink if you didn't build red yet. So what's going to happen is that red's build and done, and orange build and done, and then pink's build and done. So as you can see, this can be really slow. And as it's so slow, like it spends more time on CI, and then it starts getting expensive. And then somebody comes to you, like a manager or somebody that handles the build, and say, look, monorepos are not a good idea. Maybe you should break it down and stop building everything. Like, you don't need to assemble the whole bathroom if you just want, I don't know, lost myself in my metaphor. Anyways, so let's take another look how it goes. Like, we have my dependency, my package that I'm calling triangle, and triangle is going to depend on diamond. So I have two pipelines, and this is how they actually are going to work on this architecture over time. We have the linting, and then once linting is done, we have the tests, and then once both tests are done, then you have the build of the diamond, and then once the build of the diamond's done, you have the build of the triangle, and it takes a little bit longer because it's a larger app. And then once it's done, you run the integration tests, and that's it. So how can we make this better? We can parallelize some stuff. Like, some tasks don't depend on other tasks. So let's reevaluate the problem that we have at hand now. So triangle build depends on diamond build. Sorry, bad text. So it's actually the build that depends on other stuff. So we can just smoosh all the other things at the same time. So I don't need to know that my linting is fast if I want to run my unit test. They can run at the same time, because it's going to save me some CI time in this. And then immediately after it's done, I can just start building my things. But my build depends, my triangle build depends on my diamond build already still. So it still needs to wait for the second build to pass. But at this time, I'm already running my integration tests, which means that before my triangle build is done, I know that my diamond's successful, and I can already publish my diamond package. And then I run my integration tests, and then I can publish my app. So this is a little bit faster, and I mean, not a little. If you measure here, it's over 2 times faster, which means money, essentially. Like, it's a very pragmatic benchmark. Orchestrating properly your CI is actually going to save you money directly. It's that direct. But then you get to a second set of issues that we get with monorepos, which, okay, you managed to orchestrate your build perfectly, but now every time you are going to deploy a package, especially if it's an open source package, it's nice to have change logs. But even if you're consuming in-house, we need to care for our coworkers as well. And then you have dependency updates. So imagine every time somebody issues a patch change, you need to stop what you're doing, go there, look at the pull request, see that the pipeline is green because it changed just a patch. Like, people don't mess up semantic versioning all the time. I hope, yeah. And then you need to bump the version, so you need to change your package JSON and run and really make a git tag or whatever it is, your process. And then you can if you can make sure that you have the token and then publish, and then you're done. But also, there's another thing. Everybody that joins your team, you need to teach all that, because that varies from project to project or from company to company. So previous experience doesn't mean that somebody is going to know that when they join. So you need to walk them out. So it's a lot of time that goes into this. And suddenly you see that you're never done because they pile up. They just grow in amount and in time as your monorepo grows. So you're essentially failing from success. As more packages as you have, more problems you have, and less time you have to build actual features. So that's not good. But yeah, this talk got really bleak really fast. And I want to do the other way around that Kit did. So I want you to leave on a good note. And my point is that monorepos are actually a good thing. Yeah. So let's talk again about the problems we have. Module resolution, build orchestration, and hygiene tasks. So you have the setup is only done once for every project. So that's the point of it. Yes, it's hard, but you're going to do the setup one time, and that's it. And if you do that, probably you already are done for success. So you can get that elephant in the room in the beginning, and you can give it a hug, because it's gonna work for you now on. And then you can actually do what monorepos are built for. You can start sharing your code. But how? Like, now it's the point, now it's the time I start telling you what we end up doing. So as I mentioned, we really like, so the first thing we need to do is get to a reliable module resolution. As I said, that's the problem that's gonna bite us when we're not expecting. And that means we need a good peer dependency management. And that's pretty tricky to do by yourself. It's not possible. And depending on the tool you're using, it's gonna be even harder. Because they all do different. And if possible, there's also like, it's better also to think about your hard disk efficiency. As I mentioned, for me, it was, I was building something for the example repositories. And that means that eventually I'm going to have different frameworks in my node modules, like Next.js, Remix, SvelteKit, or whatever. So I don't want I don't want to punish my contributors by taking like half of their HD if they want to do something with me. And yeah, we like fast installs, right? Everybody, like, we're community very focused on performance. So the way I decided to go with that was PNPM. So PNPM has a very nice way of handling the dependencies. It's very clear. It has a nice way of dealing with versions that we're going to talk about that in a minute. So you can define on your package JSON the versions of each workspace that you have. Like, workspace are packages or apps. So I'm going to use workspace as a word, as a term, to talk about our projects. So you can define like what kind of version range you want for each package within that, and it's essentially like for us as end users of PNPM, it just works. And then another thing that's important is the pipeline orchestration. Essentially, this is something that you don't want to think about every time you're going to deploy an app. Essentially, it would be declarative. It could be something like, I'm building this app, and this app depends on this other task from all its dependencies, or it depends on the artifact of whatever other task I had to run, or it depends on specific kinds of configuration. So I want to be sure that I'm only going to run the tasks that I need to run, and I want to be sure that the tasks that need to be run before are going to, in a declarative way. If somebody's going to change something, they don't need to understand how both packages work, essentially. And yeah, I need to find a way to run my tasks, which, like, we have multiple options. When using NPM scripts, or if you already mentioned PNPM has a way to run the tasks as well. And it would be nice as well, as a bonus, if I could have some remote caching, because remote caching is going to cut my build times significantly. So for example, as I mentioned, in my case, I'm going to have like multiple apps that are going to be deployed, and each one of them is going to be a different use case. And I don't want my CI to build use case A if I'm deploying a change to use case B. And I also, if I'm going to do a change in a package, I want to only rebuild the packages that depend on this one. So remote caching is specifically important for diffing this kind of stuff and actually fetching the build artifact before, or fetching either from the cloud, or even having some caching in my system for when I'm developing, so then I can build everything at the same time in a fast way. So I decided to go with Turbo for that, because it has all the three things that I mentioned, and I just found their DX really, really great. And then now talking about the hygiene tasks, we want versioning. And this is a particular issue that I have. I like my versioning to not come with opinions on how I commit my stuff. I think they don't like. I don't like having like commit linters and stuff like this, because it just, to me personally, I feel it adds a little bit of friction. So I don't want that. I also want my versioning system to handle the change logs for me. So if I'm building a specific change, I want it to be descriptive, and I want to let my users know what are those changes and how it can affect them, and hopefully track down to the commit that generate that, because if eventually when I ship a bug, it's going to be easier for them to report and faster for me to fix. And lately, I don't want to need to tell everybody how I did it. I don't want to need to document it, and then every time somebody wants to help, they need to read 2 pages of documentation to know how to do a release and be nervous when doing. Essentially, this is the same process over and over again, so if I can get a robot to do it, why not? So with that, I chose change sets, which is basically a declarative way of, whenever you have a PR, you just, generate a change set for me. It's going to generate an automatic one, and you can go there and write in Markdown the more descriptive change. So it works really well in my experience. And then you have the dependency updates. For the dependency updates, I used a bot called Renovate, which, as you may realize by the name, it renovates your dependencies. And I need to maintain my pull request, because now, like, Renovate can actually do that for their own dependencies. So whenever they create a pull request for updating a dependency, they can rebase every time you ship a change to main or you merge another pull request. But another thing that I found out that annoys me to bits is when I ask somebody in my team to make a code review, and then other pull request gets merged, and immediately my pull request is stale. So I need to go there and keep it up to date so people can actually see the tests are green and stuff like that. So why not having a bot to update my packages and even auto-merge stuff when I want it to? So I used Kodiak for that. And yeah, as I mentioned, everything is automated, so I don't want to worry about that. And finally, so this is the tooling we got. And all this time, I'm more than halfway through the talk. We've been talking about architecture all the time, and I feel a little bad because it's a React conference. So let's add React a little bit to it. So I decided to set up also first, my first use case was Next.js in Remix, because I'm a React developer. I develop most of my time with React as well. And I also want to ship packages, and we're very passionate about TypeScript at Zata, so we don't do JavaScript every time we can. So once I set it all up, I said, okay, I might need to do that again eventually, as like, I really resonate like what Kitze said about having, I totally blanked out now with the too tired of doing this again. So that resonates a lot with me. So I created a repository template that has only this architecture setup. And then it's it. You can just use this template, generate your own stuff from it, and it's gonna get you the release, the changelog publishing, and the dependency updates. It's going to get you fast refresh and hot reloading for Remix and Next.js, because that doesn't come out of the box for Monorepos. I'm gonna show you in a minute. And you also get support to ES modules and CommonJS if you want to like ship like Node.js stuff. And it's ready to go. So I didn't know about this feature, but GitHub has this like template repository thing, which is, there's like this endpoint generate, or there's a button you can click, and it's just gonna prompt you, oh, you wanna create a repository like this one. It's not a fork. So it's really nice. I found this when I was finishing this thing. So I'm going to show that in a minute. But first, let's go with Next.js. So Next.js, you need to do like a small tweak to your Next.js config, which is very handy. This plugin called Next Transpile Modules, which you guessed, it transpile your modules within the bundle. So if you have like an internal package that you may not even want to publish it to a public repository or to a registry at all, it's gonna consider in the build. So then every time there's a change on that repository, Next.js is going to identify and just do fast refresh as if you were changing something inside the repository. So for Next.js, that's what you need to do. You just install this, hook it up, and you're good to go. For Remix, things can get a little bit trickier, because you can have, you need to define on Remix first what are your internal packages, and those internal packages on development, you need to set up them as server dependencies to bundle. So you need to put them in your bundle in development, because if not, like when you're shipping ES modules, like this work if you're just shipping CommonJS, but on development it's CommonJS runtime. So if it tries to fetch the ESM and it just blows up. So if you do this for development, it's gonna work. And then you need to set up the paths outside your repository you want Remix to watch. So essentially you just pass this array and say, oh, I want you to go to that folder and that folder and that folder, and you watch for changes there. Every time there's a change, you just rebuild and fast refresh. And finally, for TypeScript and packages, first I'm setting up the modules that are the kind of modules that I'm exporting. So the main is usually the CommonJS, and then the module key is the ESM. And I also have a path for my types. Then I define what are my default exports for require, import, and for the types again. And finally, I'm using, I think it's pronounced tsub. And I just passing this particular set of configuration, and bam, it works. Yeah, it's really nice software. So then, again, this is a feature now from PNPM. So PNPM workspaces allows you to define in your dependencies which are the dependencies that are within your global workspace. So in this case, I have a dependency called UI, which is theoretically my design system, and I want to fetch all the minor dependencies. And I have another dev dependency that is my monorepo ESLint config, and I want to fetch the latest all the time. So that's how you declare. So PNPM is going to solve that. So whenever you're going to ship it or install it in production, it's going to remove basically that workspace colon for you. So you don't need to worry, but that's the way to define the dependency versioning when you're dealing with a PNPM package. And then for configuring Renovate, there's like, first I like to add the labels dependencies, so then it's pretty clear and I can track down how many I did. Oops. And I have the updates type I want to match. So as you can see, the major updates, I still want to manually do them because I find them to be a little dangerous, even if all my tests are passing. And then besides the dependency label, I also adding this auto merge for those specific types of dependency. This auto merge is by default what Kodiak is going to be looking for. So whenever there's an auto merge label, Kodiak says, oh, if auto merge labels are there and my branch protection rules are met, everything's passing, I merge directly. So that's essentially what's happening here. When I define the auto merge, so you can set this string for anything else. You just need to keep them in sync. And then I'm basically saying to it that bot is going to create, and I want you to merge every minor and patch dependencies for my things. And then finally, like as I mentioned, like this is all ready to be used. If you open GitHub right now and you go to this Apex monorepo, there's this button, use as template. And this is just going to guide you through the UI, and then you have a repository. I don't even get to know it. And to show you, because a talk is not complete without a little bit of live coding, I want to show you how fast it is. So I have here 2 Chrome windows. One is going to have each one is going to have a different app. Sorry, like it's a little bit crumb here. So essentially what I'm going to do is I'm going to run my dev task that's going to build all packages that I have with Turbo. So everything is built, and now I can reload and I have my apps. So my web app is an Next.js app, and my documentation app is Remix app. And they're both consuming this button from my packages UI, so essentially my design system, as I said. So to show you how the fast refresh and the hot reload works, I can change something here and I can just command save, and it's gonna work for them. So that's essentially the setup that I have on this monorepo. So if you do that, you just need to, once you install it, it's gonna work out of the box. And how do I switch my tabs? And essentially there's like, it's not like plug and play. There's some stuff you need to do still. You still need to give access to the bots. I didn't mention, but ChangeSet has a bot that's gonna poke you every time you're sending a pull request. So look at this beauty. Like I didn't do anything. So I just created the repository and I have all this. So essentially like this ChangeSet bot, every time there's a pull request, it's gonna sniff if there's a ChangeSet defined. And if there isn't one, it's going to say, oh, you didn't issue a change set, so this pull request is not going to be released. So, yeah, are you sure you want to do that? And the way it works for the release is via GitHub Actions. So the pull request also, the branch repository comes with a release workflow on GitHub that's essentially going to install your dependencies, see if it's a release pull request. If it's a release pull request, it's going to publish to NPM or whatever registry you want, but by default NPM. And yeah, and the CI is going to run every time you push to main, or you have a pull request being open or synchronized, and it's going to use your remote caching. There is also the instructions here to set up your deployment for the apps. So essentially what you want to do is every time you're doing continuous deployment, you want to actually, from your project, change your directory back to the root of your repository and run from Turbo. So then Turbo can actually connect to your remote caching, whatever it is. And if there's something to be optimized, if there's something to just fetch instead of rebuild everything, it's gonna work, essentially. And yeah, that's all I had for today. Thank you very much for listening, and thank you. And I'll be around, so find me anywhere if you want to talk about it. Always up for it. See ya.